Hello and welcome to today's webcast brought to you by Cabling Installation and Maintenance. Today's event, The Evolution of Enterprise Zone Cabling, will be presented by Clark Kromenacher, Product Manager with Panduit Corporation. The webcast is also being sponsored by Panduit. Our thanks go to Panduit for that sponsorship and to Clark for delivering the content you will see during this seminar. Clark has been Product Manager for racks, cable management, and zone products with Panduit for 6 years. He has more than 20 years' experience overseeing product applications, marketing, and managing high-tech product lines in his current role with Panduit, as well as previously with Rockwell Automation. Clark recently received a patent as co-inventor of a vertical patching technology. Today's webcast will discuss how structured cabling has evolved over time and how to successfully deploy a zone cabling architecture within an enterprise in order to reduce costs and save energy. It also will discuss how a zone cabling architecture can support smart and connected buildings. Clark's presentation will speak, at least in part, from the practical example of his own company's world headquarters building, which is designed around a zone cabling technology. We'll hold a question and answer session at the conclusion of the presentation. You can submit questions at any time by clicking the Ask a Question button that you see in your presentation window. Also, if you're running pop-up blocking software, you'll need to disable it to view this webcast. Additionally, we recommend that you close other applications on your computer for best performance. For your convenience, this presentation will be available on demand within 24 hours of this live event. A reminder email message will be sent to everybody who's registered. That message will include a link to the archived event. It will also be accessible from the webpage cablinginstall.com. Also, in addition to supporting audiences on the Internet using Adobe Flash and Microsoft Windows Media, we at Cabling Installation and Maintenance now offer webcast viewing via Apple tablets and phones that run on iOS 4.2 or later. So you now have access to both live and on-demand web presentations from your iPad or your iPhone, as well as from your standard desktop and laptop devices. Finally, this seminar qualifies attendees to receive 1 continuing education credit from Bixby for the following professional credentials: the RCDD, RITP, RTPM, Installer, Technician, and Certified Trainer. In order to receive the attendance certificate that enables you to obtain your credit, you must remain online throughout the duration of this webcast. Upon its conclusion, you'll see a pop-up window on your screen letting you know that you've successfully completed the seminar. Then a message will be sent to the email address that you provided when you registered for this webcast. That email will bring you to your attendance certificate. So it's a couple hops from the conclusion of this event to your attendance certificate. With that housekeeping out of the way, it gives me great pleasure to introduce today's speaker, Clark Kromenacher. Clark, whenever you're ready.
Patrick, thank you for that introduction, and also thank everyone for participating in the seminar. Today we're going to talk about, as Patrick mentioned, the evolution of enterprise zone cabling. And in this perspective, when we talk about enterprise, we typically talk about, at least here at Panduit, about the office environment. So that's just separated from the data center. The enterprise is going to be, our discussion is going to be revolve around, office-type implementations of what we call zone cabling and zone cabling implementation. First off, let me introduce you to Panduit, the company that I work for and helped me put this together. Panduit is a world-class developer and provider of leading-edge solutions that help customers optimize the physical infrastructure and mitigate risk through simplification, increased agility, and operational efficiency. So Panduit's been in business since 1955, so a long legacy of innovation. We have a global presence, local focus, and customization. So we do a lot of work with our valued customers, supporting their efforts and providing solutions to them in a standard type orientation as well as a custom type orientation. Over 4,000 employees work here at Panduit, and we're in 112 countries around the world selling and supporting our products as well as our customers. So Panduit has a solutions approach to what we provide our customers and partners. So not only do we provide components that people use in things like zone architectures and data centers, but we provide solutions that combine all these components together in some very effective configurations that our customers come to value. So we do this in the data center. So we also do this in the enterprise, which is what we're going to kind of talk about today. And we also participate in the industrial automation sphere, where in all of these, what drives all of our participation is the growth of Ethernet through all of these different areas. Our agenda for today is to cover these topics. First, we're going to talk about traditional structured cabling and what is the common practice today in the enterprise. Then we're going to cover the concept of zone cabling topology and what is different about zone cabling topology over a traditional structured cabling architecture. We're going to cover some information on how to deploy a zone architecture and some concepts as to what a designer, an installer might be considering when they want to implement a zone architecture. The features and benefits of using a zone architecture. So obviously there has to be some value in going from a traditional structured cabling format to the zone architecture, and we're going to cover the features and benefits of doing that. How zone cabling and zone infrastructure can enable smart and connected buildings, and so this has to do with consolidating a lot of the systems that are in buildings today into more of a condensed backbone or surrounded or encompassing Ethernet communications to all the devices that run a particular building and monitor its performance. We're going to cover some of the Panduit products that are offered that actually contribute to a zone topology and are used in developing a zone in an enterprise environment. We actually eat our own food, so to speak, in that we implemented the zone technology here in Panduit's world headquarters. So we're going to talk a little bit about how it was implemented here in the building I'm presenting from today, and you'll get a view as to how that's working. And then we're going to wrap up with a quick summary, and I believe after that we'll be able to handle some questions. Okay, first off, let's talk about traditional structured cabling. So this is typically if we look at a floor of an office building or an enterprise in our case, and obviously all the workers on that floor and in that building need to have some connection to the internet to be able to do their jobs. And what we normally see is we see a telecommunications room. Here it's displayed on the lower left-hand corner of the image, the TR, a telecommunications room somewhere on the floor of a building where cables are then run either in the ceiling or in the floor to each of the individual workstations where people get their jobs done. So throughout a building, there may be a home run architecture like this on every floor of multi-story buildings. So we have a situation where we have multiple, what we call a home run type architecture, where all the cables come from the telecommunications room and go to the workstations. In a lot of ways, it's somewhat inefficient and it's costly to implement a home run system, especially in the modern age where what we're seeing a lot of is changes occurring in an office area or in an office layout where the original plan might be to have workstations located at certain areas on a floor of an enterprise. What's happening more today is a lot of change comes into the picture where some offices may be removed or moved to make room for conference rooms or other type of things that are needed in the enterprise area. So one of the common things that happens is if we look at the upper right-hand side of that image, at those desks, there's about 6 workstations in the upper right-hand corner. If that was to be made into a conference room, using this type of architecture, what we would find is that we do not need all of the cabling that's going from that telecommunications room to those 6 workstations up in the corner. And we would end up having to, in many cases, remove that unused cabling that's in the ceiling. So there's a lot of concern these days about having any unnecessary combustible products that could be in a ceiling or in a floor when they're not being used. So a lot of times what happens is if the architecture has changed, the layout of the office has changed, a lot of these cables either have to be added or they have to be removed if they're not going to be utilized in the future. So therein lies the advantage of zone because we avoid doing a lot of those removals and adding of additional cables when we actually rearrange our work environments. So what does the zone cabling topology look like? Well, the zone cabling topology looks more like the image you see on your screen. So instead of having individual cables going to each workstation in a enterprise or office area, what we have, and if you look at the image, we have zone enclosures or zone devices that are located strategically throughout the enterprise or work area. And so what we do then is we have the red lines indicating trunk cables of probably about 24 cables that would go to these zone enclosures, and the zone enclosure then allows you to patch the individual workstation in from the enclosure itself. The zone enclosure can actually be mounted either in the ceiling, it can be mounted under the floor, and it can also be mounted on the wall. So there's different ways to implement the zone architecture. But if you think about what we discussed in the previous slide, where an area might be converted to a conference room where we would not need all of those cables in the ceiling, using the zone topology, what that allows us to do is basically remove the desks, and we just remove the patching cables that go to the zone enclosure and then to the workstations. We can remove those, and we can leave the zone enclosure and the trunk cable intact in the ceiling or floor. And so that saves a lot of effort with regard to reconfiguring the entire cabling on that particular floor, and it also leaves us open to any future changes that might come down the road where we may want to go back from a conference room to an office environment or maybe something completely different. We can continue to use that zone enclosure throughout the life of the building to allow us to more flexibly reconfigure and deal with changes that we have to do in our work environments. So a zone topology, what it allows us to do is become more cost effective because we don't have to change, we don't have to remove those long runs of cable or add long runs of cable to the telecommunications room. We can just add them to the zone enclosure. It's flexible, as we discussed earlier, so that changes can be made throughout the life of the building with regard to reconfiguring the office. It's easily accessible, so the folks that have to go in and actually make the change with the cabling, they can go into the zone enclosure, which is going to be very close to the workstations, and make those changes so that the cabling is very accessible and it's scalable. So, and as I mentioned earlier, we can build this out. We can continue to expand the zone solution throughout the building, and allows us to change as time goes on. So here's another image showing the zone cabling. So what typically happens in a building that does not use zone enclosures is that you'll have a telecommunications room, and the building will be at some point in time designed and then built, and cabling will be in the ceiling or on the floor going to each individual workstation. Well, what happens over time is as you're adding and removing cables, what happens in the floor or ceiling is it begins to be, quite frankly, it begins to become a mess because the cables are kind of routed wherever they can be sent through, and they don't follow any real format. So this is another advantage of the zone cabling system, is that once we implement a zone cabling system at the design of the building, we will end up with a very neat and clean pathway in the ceiling or in the floor that carries those cables that will essentially remain untouched throughout the life of the building. And it's a much easier thing to deal with over time to have a fixed location for those cables, a consistent location for those cables that's not going to be changed. So if for some reason you do have to go back into that ceiling or that floor to look at the backbone cabling, you know exactly where it is, and you won't have to trace random runs of cabling throughout that structure. So this image, we're pointing out where the zone enclosures will be located in this environment, and also where the telecommunications room would be in this environment. And also on the lower left-hand side of your screen, we have just a comparing image showing what most in-ceiling pathways look like today and what it can look like with the zone solutions implemented. So let's talk about in a little more detail zone architectures. And there's actually two basic concepts that I'd like to impart on you. One is the centralized network, the concept of a centralized network. So the centralized network is where we have all of our equipment in the telecommunications room. So our active equipment is in the telecommunications room, and our zone enclosures are purely passive devices. So that's a centralized network. So the zone enclosure in this configuration would be used for patching to the workstations. So we can see from this diagram, we point out where the network switch is located in the TR or telecommunications room, the horizontal cable or the trunk cable that would go to our zone enclosure, the consolidation point enclosure itself, the horizontal cable that goes from the zone to the work area, and the individual patch cords that would go from a faceplate, for example, to the actual computer. So this is so the whole concept, again, centralized network, we have the zone enclosures are passive. Oops. Okay. And taking a look at, again, centralized network, consolidation point layout for a raised office floor. The previous slide we were showing an in-ceiling installation, and so here we have a similar concept, except the cabling is being run in the ceiling in the floor as opposed to be running in the ceiling. So here we can see the network switch. We can see the horizontal cable to the consolidation point enclosure that's in the box, and the horizontal cable going to each individual workstation, and the patch cords that will then go from the outlets to the actual computers that your workers will be utilizing in their jobs. So standards, what standards apply to consolidation points enclosures? So the consolidation point is an interconnection point per TIA 568B.2 and 568B.3. The standards say cross connections are not allowed, so these are just interconnects. They must be located at least 15 meters from the telecommunications room, and the standards limit the up to 12 work areas or 24 to 36 ports. It has to be located in a fully accessible permanent location tied to the building structure. It can be located in a plenum environment. And for those of you that are not familiar with a plenum environment, that would be an area where there's airflow necessary to the building. And a plenum environment has some special requirements because it's not allowed to have flammable material in a plenum, because obviously if there's a fire or emergency, we don't want smoke from any devices to be transferred through the rest of the building. So devices that are plenum rated will not generate smoke in an emergency environment, emergency situation. So solid cables extend from the consolidation point to the work outlet and terminate to a connector. And so let's just take a look at this. I think what we're going to see on this slide is we're going to see some different options for centralized network zone solution. So we just previously looked at a in-ceiling version of a zone enclosure. So we can put a zone enclosure on a wall. And this is for some installations, that might be all that's available is a wall installation for a zone enclosure. We also have, there's smaller enclosures that can fit either under a floor or in a ceiling, and they have the ports built on the outside of them. So there are 24 and 48 and even other devices that have different port counts that allow you just to have an enclosure that can be put in an available space and be used for a zone solution. There's another concept with regard to centralized network, and that is a MUTOA layout, which is a little bit different. It's still a centralized network concept, but it falls into a category called the MUTOA. MUTOA stands for Multi-Unit Telecommunications Outlet Assembly, and it's a special exception in the TIA standards for a way to implement a zone solution. So in this diagram, what we show is the network switch in the telecommunications room with all the active equipment in the telecommunications room. We have a horizontal cable or a trunk that goes to the zone. In this case, it's the MUTOA. We show the actual MUTOA enclosure, and if you notice what's different with this slide versus the previous slides is this is actually a small enclosure that's mounted to, in this case, a pillar in the building. And then we have patch cords coming from this MUTOA and going directly to the individual workstations. Now, the advantage of doing this is that if you have a work environment that changes quite frequently, this makes it very easy to change the way your workstations are configured. And so we see a lot of applications for things like this, particularly in banking and brokerages, trading houses and trading floors, where they may have a trader who may want to add another computer monitor or another phone on his desk, and so they'll have a close-by zones-type solution where they can then be connected with additional capability very easily and very quickly at that. So MUTOA standards. MUTOA, Multi-Unit Telecommunications Outlet Assembly, is codified in TIA 568B.1. The horizontal cable remains intact when the open office environment is changed, so that we're talking about the horizontal trunk cable per the image below. It can be routed through work area pathways through the office furniture, or in some instances the cable just lays open going to the actual computer or device. The telecommunication room to MUTOA, the jack to jack, and the MUTOA to work area device is plug to plug. The standards limit to 12 work areas or 24 to 36 ports. There's also some limitations because we have these extra connections. There's some limitations to lengths that are in the standard. So the TIA 568B.1 standards will chart out the acceptable lengths for cables that we're using in a MUTOA. It must be located in a fully accessible permanent location, a building column or wall, and shall not be located in a ceiling or under a floor space. So to quantify as a MUTOA, it's still a zone device. If you want to call it a MUTOA, it shall not be located in a ceiling or under the floor. The MUTOA device does not need a plenum rating. However, many of the devices that Panduit provides do have a plenum rating on them as well. So here we're switching through some different options for your MUTOA. So previously we had a 24-port kind of a home run plate-shaped device. That's one option. We also have, We also have some smaller MUTOAs that can be as small as 6 ports. That's what the image is showing here. And so we have, this is a MUTOA that is designed to be aesthetically pleasing in the office environment, so we have those available. And also, let's just talk a little bit about the deployment of technologies using in-ceiling or wall-mount enclosures. A lot of what's driving the use of multi-unit telecommunication outlet assembly and zone in general is the whole concept of PoE, Power on Ethernet. And so what that does is it makes a zone solution even more attractive because you can simply plug the phone into the zone enclosure, a nearby zone enclosure, or a computer. So it makes the zone enclosure kind of a general purpose termination point for almost any device. And it also limits the power necessary on a desk or in a workstation. So a Power over Ethernet device can be installed in a ceiling or wall-mount enclosure. That would include a zone. Allows easier integration and implementation of voice over IP. And it's a scalable platform for powering voice over IP phones. So, and by that, if you want to add another phone, you just plug one in if you have a zone enclosure that's PoE enabled. Also for wireless LANs, the zone enclosure allows you to connect to wireless LANs easily. The LAN controllers can be installed in a ceiling or wall mount enclosure. Now the next thing I'll be covering is active zone enclosures where we can actually mount a device. And so the topic here, wireless LAN, we can put LAN controllers in zone devices, and those would be the class of zone devices that can take active equipment, and we'll be talking about that very shortly. So to kind of sum things up, we have the zone cabling network infrastructure. The zone cabling topology provides a cost-effective alternative to deploying your network infrastructure by increasing the network's flexibility, scalability, accessibility, and so on. So it's a very useful technique, and it's something that we see more and more in new building designs going toward a zone-type solution. So let's move on to the next step. And so here's some of the benefits for the zone cabling. Simple and easy moves, adds, and changes. MAX is commonly the common name used in the industry. Shortens the distance required to make moves, adds, and changes. So instead of having to make the change all the way to the telecommunications room, you make the change to the zone enclosure. It's more intuitive to manage since the device you're patching into or connecting to is close to the actual workstation itself, and flexibility, as we discussed earlier. So as the work area changes, the system is very flexible. It also has a lower total cost of ownership. It's a cost-effective way of managing cabling infrastructure. It's flexible, scalable, and accessible. There's less disruption of network and downtime to users. So again, it has to do with the fact that you're making your changes very close to the work area. You're not going all the way back to the telecommunications room to make a lot of these changes. And it reduces the number of users affected by downtime. So it's much easier to see what you're changing and who that change will be affecting in the work area. So let's take a look at distributed networks and telecommunication enclosure standards. So here we're talking about distributed network. So a distributed network is a situation where we're actually taking active equipment, so we're actually taking switches and gear potentially out of the telecommunications room, and we're distributing those active pieces of equipment throughout the building in zone enclosures. So a distributed network could look something like this, and a question may come up in the design of a building or in the reconfiguration of a building. The question might be, can a single telecommunications room cover the entire floor? Sometimes that's not possible. Depending on the users, the size of the floor, you may need 2 telecommunications rooms for a building. But we can actually implement a zone enclosure. We can do a zone solution that has a switch inside of it, an active zone. We call this a distributed network, and it is defined, codified in the standards as a tiny telecommunications room, and it's covered in TIA 569B. So the tiny telecommunication room must conform to telecommunication room requirements in 568B.1. So it functions just like a telecommunications room. So what the result of this is that if you can remove a telecommunications room on one floor of your building, you of course have less floor space being taken up, and you have more opportunity to put more workers in there or use that floor space for something else. Can be incorporated with other zone cabling topologies, so you can actually use a distributed network zone enclosure with active equipment and perpetuate that into a passive consolidation point or a passive MUTOA type device to extend your network capability throughout the building. It can extend the horizontal cable when using a fiber backbone in a collapsed backbone concept. So, you know, to answer the question, can a single telecommunications room cover the entire floor when you have a large number of users? The answer, of course, is yes, it can. So this is showing in a conventional building how 2 telecommunications rooms might be the issue that we're trying to address. And if we build this out, we can see that by going to a zone solution that we can limit the telecommunications room count by taking some of that switching equipment out of the telecommunications room and distributing it throughout the enterprise in an active or distributed network type of zone architecture. So distributed network, zone cabling benefits. So it's very simple and easy for moves, adds, and changes. It's a lower cost of ownership, total cost of ownership. It can extend the backbone cable. You can extend the backbone cable with fiber to the zone. So that's another concept, so that if you can think about it, if you're actually taking switching gear out of the telecommunications room and you're moving it into the zone enclosures, it may not be advantageous to use copper in that scenario. So it may be more advantageous to go directly to fiber to that switch in the zone enclosure, and then possibly have copper going to the individual workstations. That would set you up or future-proof your installation, so to speak, so that as time went on and performance demands increased, you would have that high bandwidth copper pathway, or excuse me, the high bandwidth fiber pathway coming from the telecommunication into the active zone enclosure that you can then leverage to provide higher performance as your advancement deemed necessary. So using fiber increases the maximum horizontal cable distance. It's not limited to 100 meters like copper is. It can go up to, I believe, it's 300 meters for fiber. Lower installed cost. There's fewer cables to buy and install. So if you run one of these trunk cables to an active zone enclosure, you're going to have less copper there because you're either going to have a couple cables of copper or even one pair of fiber going to that zone enclosure with the active equipment. Less floor space required because you're potentially eliminating a telecommunications room in some installations, and reduces network installation costs by over 15% with fiber to the zone. There's actually a hang on a second here. There's actually a website that can help you, and it's a fiber optics LAN section of the TIA website. And I don't know, I do have the website here in front of me, and if anyone's interested, we can provide that. But that provides a cost model, so where you actually are considering going to the fiber to the zone type of architecture, it's a way to enter all your variables and try to justify the savings that you would get by going with that. So going to fiber is the highest possible bandwidth option. It's an opportunity to route fiber closer to the desk, 10 gigabyte to the desk using Cat6 cable from a switch in the zone enclosure. And as I mentioned earlier, it's a future-proof solution that you can implement in your buildings today. So what's the zone evolution? So we talked a little bit about the zone in a data concept, so providing data to our workers in a building through the zone topology. What is the evolution of zone? Well, a natural evolution of zone would be into these areas you see on your screen. So into security, into things like access control, climate control, heating, ventilation, air conditioning, and lighting. One of the technological trends that we see occurring, and I'm sure everyone out there sees it as well, is almost everything is going to an Ethernet-based communication technology. So what that allows us to do is not only use Ethernet and the switching and gear that we have today for data communications, but we can more and more use this equipment to communicate to things like security devices, provide access control, climate control, and so on, and lighting through the Ethernet backbone. So it's the whole idea of collapsing the backbone in your building to a smaller quantity of Ethernet-capable cables and getting away from some discrete or disparate type communications protocols that have traditionally been used in things like security devices, access control devices, HVAC devices, and lighting devices. So it's an evolution of zone that will take us to more Ethernet-enabled products that allow us to use zone in more and more in different ways. So taking a look at intelligent buildings, as I mentioned earlier, the industry, all of the devices, all the concepts we talked about earlier, they're all moving toward an Ethernet-based system. And one way to frame that is to think of data and voice 5 years ago, where you might have an Ethernet, 5 years ago you might have an Ethernet cable to your desk for your computer, but more than likely you had a separate cabling system that was basically your telephone system, and they were totally separate systems in your building. And of course, what we're seeing more and more today is those are collapsing on each other, where we're getting data and voice on the same cable coming to your desktop. So what happened there with data and voice is happening with the rest of the building infrastructure. So integrating building systems and data communications into a single network, and we talked about some of these: security, access control, climate control, lighting. The major drivers of this consolidation into Ethernet, the Ethernet realm, are environmentally friendly. So if you don't have to use as many cables in your ceiling or in your floor, that's environmentally friendly. If you can go to fiber, that's even more environmentally friendly. There's also higher expectations from building owners. Building owners want to very closely manage things like security and heating and cooling in a building because everybody knows energy is very expensive these days, and if there's any way they can, for example, monitor the population of the building and turn on heating and cooling as appropriate, that's going to save that building owner money. And what's going to enable that ability is to go to an Ethernet type solution, and one that most likely is going to use Zone as part of that solution as well. Tenants, employers will have a more comfortable environment to work in. Employees will enjoy it more, and so there's overall cost savings by going through the intelligent building, implementing Zone, and looking for solutions that collapse that backbone away from different protocols and communications devices that are used in some of these systems and going to an Ethernet-based system. So try to sum this up. So what we see here is pretty much what buildings look like today. So we have a number of different systems in every building, whether it be access control, security, fire control, telephones, and whatever. Today, in many cases, they are operating off of all different systems. So we have a lot of different systems, and what sometimes happens is these different systems at some point interface into the Ethernet backbone. And so what's happening is that collapsing that backbone, we're going Ethernet directly to all of these systems that control things like fire, lighting, physical security, elevator, visitor access, energy, and so on. So this is all part of the concept of the intelligent building, and I want to impart on you that in the center of the diagram on the right, we can see the little star boxes that indicate switching type gear. That in a smart building, that gear would be located in a zone enclosure, located somewhere in the building to communicate with all those different devices. So intelligent buildings, how do we converge building systems and data communications? Well, one way is to utilize only building systems that are Ethernet based, and it's not possible to do that 100% today, but I believe as time goes on, we see more and more devices out there that for lighting, security, heating, ventilation, air conditioning, and so on, are moving toward an Ethernet-based communications protocol. So if you are working on a new building, if you're involved in the design of a new building or remodeling of a new building, I would implore you to keep your eyes open for devices that you can implement that are Ethernet-based, and that get away from some of these other protocols that might be twisted pair-based that will really complicate your system. So we want to look at Ethernet-based solutions for our buildings. Utilize preferred building systems with a zone network architecture, and I think you're going to find as you look into the intelligent buildings that there's probably no way to implement an intelligent building without using zone enclosures. So it's kind of hand in hand how these two concepts are going forward, where zone enclosures will be used to house these devices that talk to the various aspects of the control and heating and ventilation of the building. Converge network equipment and building controls in the same environment. So hybrid solution with a single Ethernet network to the zone and building systems controllers located in the zone. So one of the ways to do this is look for those Ethernet-enabled devices and have those in the zone enclosure. And if you do have to go outside the Ethernet realm to different protocols, you can still do that with a zone enclosure as well. So you can branch off that zone enclosure with an Ethernet solution inside of it and go to different devices that may be RS-232 based, they might be RS-45 based, or have some other protocol. That is certainly possible. So just talk a little bit more closely about security, how those might be implemented in an intelligent building and utilizing a zone type solution. So everybody knows IP-enabled cameras are becoming very common, And also what's becoming common is power over Ethernet versions of cameras. And so what we're showing here is that if we look in the upper right-hand corner of the slide, we kind of show two devices. So we have a switch at the top there, and we have a device called a midspan. A midspan device may or may not be necessary, but that would put power on the Ethernet cable so that it can directly power things like security cameras, in this case, wireless access point devices, or phones. So the switch and in this case, the switch and the midspan device, those could be located in a zone enclosure that might be in the ceiling or in the floor or even on the wall. And so we're looking at easier integration and deployment of cameras, in this case of security, and a scalable platform for powering cameras. So if you need to add another camera, for whatever reason, it's very easy to simply plug that into a midspan device or a PoE-enabled switch that is already located close by in a zone enclosure. And so here we're showing how that system migrates. A camera can be easily integrated into a floor and into a solution, again, by using zone enclosures and PoE-enabled devices. So in a converged environment for an intelligent building, efficiency, optimization, and intelligent communication result in significant cost savings. So typically, at Panduit, right now I'm talking to you from an intelligent building here at Panduit, and we implemented a lot of these strategies that we just covered. And so what we're seeing here, because of that, is we're seeing an energy savings of about 30% using zone solutions in an intelligent building. We're saving carbon, up to 35% carbon savings by the energy and heating and cooling that we're having not to use. Water use savings of 30 to 50%, and waste cost savings of 50 to 90%. We recycle a lot here. Rainwater is utilized, and so on. And cabling infrastructure savings, 60 to 90%. So again, if you don't have to run individual cabling to every workstation, and instead use a concept of running a trunk cable to a zone enclosure and then branching out the zone enclosure to the workstation, you could save a lot in cabling infrastructure. So just to talk about some of the devices that we have here. So going back to the centralized network, what devices would we use? What actual devices would be used in a centralized network or a consolidation point? And so again, just as a reminder, a centralized network is where you have the active equipment off in the telecommunications room, and your zone enclosure, your consolidation point enclosure, is a passive type device, and we're doing patching in that. So we have in-ceiling enclosures, so this device actually can take up a 2x2 ceiling tile in a building, and it folds into the ceiling, and it is not even noticeable by those who work around it, but it is very convenient to those that need to hook up data communications to workstations in the area. They simply go up in the ceiling and swing this device open, and they're able to patch to or reconnect and reconfigure workstations. We also have wall-mount enclosures that do a similar task. Now, this particular image shows a punch-down consolidation point, but we also have devices that can take patch panels as well. So we have a variety of options available in that regard. We also have underfloor consolidation point enclosures, and this is actually what is being used here at Panduit headquarters. So all of our workstations here at Panduit headquarters are connected to the main telecommunications room on each floor by using a zone enclosure exactly as you see here. So this device fits into a raised floor tile in an office, and it has a lockable cover that goes on it. Once it's installed and the cover is installed, a carpet section is placed over this device, and again, as it is impervious as far as the work environment is concerned, no one really knows it's there except for the people that need to work on a system. They can go directly to this enclosure, which is going to be close to the workstation, and make any necessary changes. And also, I'll have you notice the image on the left. We obviously see the blue data cable going to the enclosure, but please notice the orange cable. That's actually building automation devices, building automation wiring. So we're using these enclosures not only to patch data, but we're using it as a consolidation point for some of our building automation systems as well. So on centralized network consolidation point enclosures, so these are some other enclosures Some of these enclosures would qualify as MUTOA, multi-unit telecommunication outlet assemblies. So we have underfloor enclosures on the upper left-hand part of the slide. That's a 24-port device. That device is plenum rated, so you can use it as a MUTOA that can go into an office environment, but it's also usable under the floor or in the ceiling. Going from left to right on the slide on the top, we also have PanZone cable assemblies, either jack to plug or plug to plug available. And what's significant about these cables is that they are plenum rated as well. So they're rated to be able to be used in zone enclosures that would be in those plenum areas. And to the far right on the top, we have punch-down consolidation point enclosures, simple devices. Some people still prefer to use punch-down, so we do have those devices available. And going to the lower half of the slide, on the left side, we have the raised office consolidation point enclosure, which is used here at Panduit headquarters. We have the PanZone cable assemblies, which I covered earlier. And we also have a 48-port version of a consolidation point box. And this, again, is a device that it's plenum rated, so it can be used in a ceiling, in an air handling space, or in a floor. And it's rated, UL rated to be applied that way. So, and then the other concept, the distributed network. Now, the distributed network is where we actually take the active equipment, we're taking it out of the telecommunications room, or we're reducing the number of telecommunications rooms we might need on a floor of a building, and distributing that active equipment throughout the work environment. So we have a number of devices that allow us to do that as well. So we have in-ceiling enclosures, as you see on the left side of the screen, and so this device actually has 2 RU that can be used for active equipment. So you can actually put a switch in this device and have perhaps fiber coming from the telecommunications room to the switch, and then come from the switch with copper to the workstation. And this would allow you to very conveniently expand the performance of your system down the road. And this device, as you notice on the bottom image, folds up into the ceiling, and it is very obscure to the environment that there's actually an enclosure close by. So there's also wall mount cabinets that we have available. These devices are very similar to floor standing cabinets, except they mount on the wall, and these too can accommodate an active switch, an active piece of switch gear, and they can be used as a zone enclosure, either in a small telecommunications room or in an office area that might have the room to install the device on a wall. And on the bottom right-hand side of the screen, we have a wall mount enclosure. Now, this wall mount enclosure is unique. It does accept active equipment, and what's unique about it is the active equipment actually hangs vertically in the unit. The advantage to that is that this particular wall mount enclosure, once you hang that switch vertically in the enclosure, its standoff from the wall is very small. So it's probably 10 centimeters or maybe 9 inches off the wall, and it is it's very hard to detect in an office environment. It does not get in the way of what you need to do in an office environment. The other thing I'd like to bring to mind, too, with these devices is what we're seeing more and more of these days is a lot of reuse of older buildings. So there's a lot of buildings that are being repurposed for work areas for people, and there may not be room in some buildings for a full-size telecommunications room, and so zone solutions fit there as well. So the wall mount cabinets, the PanZone wall mount enclosure, the ceiling mount enclosure can be considered tiny telecommunications rooms. So there's cases where, for example, in historically significant buildings, you may not have the ability to knock a wall down and put a telecommunications room in. For example, here in Chicago, Google recently purchased the Wrigley building downtown, and so there's a lot of restrictions there with regard to what they can build in a historical building. And one of the solutions to that is to go to a zone-type solution, distribute the small telecommunications room into the space that you have available, and therefore, you can avoid, you can get the performance out of your building that you need without having to install a large telecommunications room. So also part of the zone solution, we have our wireless enclosures. We sell enclosures. We actually take the wireless access point that's available from a number of our partners, Cisco and Aruba, and put them into an enclosure. The manufacturers of the wireless access points will often say tell the user just to mount the wireless access point on the ceiling or mount it on the wall. What we find is that many of our customers are concerned about doing that because mounting it on the ceiling grid or mounting it directly on the wall leaves the device open to pilfering or damage, and we'll get cleaning personnel will try to clean the wireless access point, or maintenance personnel will try to paint the wireless access point. So what we're finding out is there's a lot of customers that want to enclose that wireless access point into an enclosure. So Panduit has a wide range of those enclosures. We call them zone enclosures to put a wireless access point in. So we have wall mount solutions, we have ceiling mount solutions, and so we have some aesthetically pleasing ceiling mount solutions that take some of the latest wireless access points. So this particular wireless access point is for the latest Cisco devices. It integrates very nicely with a ceiling tile, and it's very secure. So all of our enclosures, one of the nice things is they have a lock on them. So once the device is put into the zone enclosure, whether it be a switch or a wireless access point, there's a key lock available that will lock that down so that the accessibility is limited. So we have those available as well. We also have this is a zone enclosure that is used in the enterprise, and is also sometimes used in industrial environments. So this is a NEMA 4 rated IP66 wireless access point enclosure. This device, we do get requests for being able to provide wireless access capability in things like courtyards and outdoors, and so this would be a device, an enclosure we can recommend. It is a fiberglass enclosure, so in many instances, the wireless access point, in this case, can be installed directly in this enclosure. And since it is plastic, basically, the radio frequency, the radio waves will be able to go through the plastic very easily. And this device can be mounted in a courtyard or perhaps in an industrial environment where they need a secure enclosure that's watertight to prevent moisture from getting into that equipment that's inside of it. So, just a summary, we walk the walk and talk the talk. Panduit has implemented Zone in our world headquarters, so we're very enamored of the technology. We find a lot of value in it, and we think many of our customers will find value in it as well, the more we talk about the availability of this type of solution. So taking just a schematic diagram of the Panduit world headquarters, what we show here is we're showing the consolidation point enclosures. Those would be the zone enclosures, and in the far left, the wireless access point enclosure, just showing how we use those in our building to integrate or communicate to the different systems that are here at the Panduit world headquarters. So all things like energy management, voice over IP, security, fire safety, and so on, they all go through the zone consolidation point enclosures here at Panduit. So they're mounted either in the floor, on the wall, or in the ceiling here to handle all the functioning here at Panduit World Headquarters. So just as a quick summary, work area cabling is critical to a well-maintained distribution system. However, it is generally non-permanent and easy to change. So that's the whole concept behind Zone. So we'd like all of you today and tomorrow to think zone cabling, think of the advantages, and hopefully you'll be able to implement it in your next project or in your next design. Thank you very much.
Park, thank you very much for that information. And we're going to get started with Q&A here in just a minute, and I think we're going to be able to answer at least a couple of questions before we hit the top of the hour. But a couple of things. During Clark's presentation, he mentioned the fiber optics LAN section of the TIA and the fact that organization puts out a cost model that includes costing models or costing scenarios for the type of architecture described in this webinar. A number of you asked for information on that. So again, it's the fiber optic LAN section of the TIA, and their website is FOLS for fiberopticlansection.org. So FOLS.org will bring you to their website. One portion of their website is devoted to that cost model. And the way that it works, my understanding is the way that it works is upon registration, a working cost model will be sent to you. So if you want to go to that site and register for it, they'll send a cost model to you, which I believe will allow you to sort of plug in numbers that you're going to be working with and again, lay out that cost model for you. But in an overall sense, fols.org is the place to start. And again, once you reach that website, you'll see you'll see a section of that site that's devoted to the cost model. Also, because we've got just about 5 minutes by my clock before we hit the top of the hour, I know we're not going to get to all the questions that came in, but please know to everybody who submitted a question that if you've submitted one that's not addressed here verbally today, please know that the questions have been captured by the mechanism that's delivered this web seminar to you, and it's possible that questions not answered here verbally may be, if you submitted a question, you may hear an individual follow-up to your question sometime in the future. So if you don't hear it answered here verbally by Clark, please know that that such an answer may be coming your way. I'm going to fall short of making all those promises for Clark, but want you to know if you submitted a question that we do have it and that it can be accessed. Yeah, thank you. Thanks. So I'll get underway before I do too much talking here, Clark, and just go through as many of these questions that we can. One comes in that says, that came on early in your presentation saying that the cost of the zone equipment, switches, and such things that you described seem like it sizes up to be a pretty expensive solution. So considering that, how is this zone cabling architecture still a cost-efficient option, given that you're talking about the investment in this other equipment?
Well, I think it's what you have to do is balance the trade-off in the equipment with your need to do changes in the workplace or in the work environment. I think we all know that labor is expensive, so if you're doing a lot of moves, adds, and changes, or you think the building is going to undergo changes in the future, you also have to, aside from the equipment, you also have to employ labor to make those changes. And what the zone topology does is it allows you to make those changes easier and more quickly with a more intuitive understanding of what needs to be done when it needs to be done. So and those are all the concepts that encompass the zone topology. And don't forget that if you are utilizing an active zone topology with a switch in it, you're actually taking that equipment probably out of a telecommunications room somewhere. So you're not really, in many instances, you're not really adding more equipment. You're actually moving it, distributing it throughout the organization. And then you're shrinking your telecommunications room down. You're shrinking the amount of power that's in that room. You're shrinking the amount of heat that's generated in that room. And another thing that's often not talked about is that when you distribute your switches around a enterprise or a building, you're actually diversifying your power as well, because a lot of those switches you're going to connect those to different parts of the circuit in your building, and so that's going to give you some power diversity. If you have some power issues or something happens there, you're not going to bring down your whole telecommunications room. You're going to just maybe one or two of the zone enclosures might be affected, and so that's going to help you out there as well.
Thanks, Clark. Moving on to another question. Question first observes that there's growing interest in passive optical networking for enterprise environments, and then asks, would that being the case, are zone cabling options and configurations changing in the industry to address the requirements of fiber-rich environments, the fiber-rich passive optical network environments that are growing at least in interest and perhaps in popularity for deployment as well?
Absolutely. We've had some good meetings with some of our major partners that are planning to use passive optical networks, and we working with them, we do know that some of the enclosures we have today will be adequate for what you would like to do in a passive optical network, but we also are working on some new solutions that will try to leverage that particular technology for the passive optical network. So yes, I guess the answer to that is yes, and I like to think Panduit's on top of it, and we are active in that area.
Thanks, Clark. I'm looking at the clock. I bet we have time for one more question before we have to wrap up. So the next question in the queue is this: what is the maximum length of the patch cord that comes from the zone enclosure?
Yeah, I think what you're really looking at is the maximum length. Since if we're talking about a passive consolidation point enclosure where we're patching in the enclosure, we don't have a switch up there. you're really talking about the overall length from the telecommunications room to the workstation. I believe that's like about 100 meters. So depending on where the distance is from your telecommunications room to the zone enclosure, your patch connection has to be with, your overall length of your connection to the workstation has to be within that 100 meters. So I think your patch cable length itself can vary, but you have to be aware of, that 100-meter length. And if your zone enclosure is 90 meters from the telecommunications room, then you can only do a 10-meter patch cord at that point. So it all has to do with the overall length, that 100-meter length, and you don't want to exceed that.
So the overall math has to add up is essentially
correct.
How it
the overall math has
out.
to add up, exactly.
Got it. Thank you. Well, thanks again. And to the members of our audience, I want to let you know that, as I mentioned earlier, all questions that were submitted today have been captured. So just to sort of put the notice out there, please don't be surprised if at some point you do receive some information, and an inquiry, actually a response to your inquiry from today. So please know that may be coming at some time. For now, on behalf of Cabling Installation and Maintenance and its parent, Penwell Corporation, I thank today's speaker, Clark Kromenacher, as well as our sponsor, Panduit Corporation, for the presentation that you just saw. A reminder again that this presentation will be archived within 24 hours. It's going to be accessible from the website cablinginstall.com. Also, just a moment, we'll sign off, and you'll see a window on your screen that indicates you've successfully completed this event. That window appearing on your screen will be followed by an email to you that will bring you to your attendance certificate for today. If you do not receive such an email, please send us an email at the following address. It is webcast material, W-E-B-C-A-S-T, webcast material, M-A-T-E-R-I-A-L, all one word, webcast material at Penwell, which is P-E-N-N-W-E-L-L.com. If you do not receive your certificate but you send an email to that address, we will verify your attendance here today and issue a certificate to you. So with that, I thank everybody for joining us today. Certainly hope that this web seminar met a great deal of your information needs, particularly about zone cabling. And once again, thanks to everybody for joining us. Good day.